So in this lesson, we're interested in listing the conditions that we need to have between two triangles in order to guarantee that the triangles are congruent. Guarantee the triangles have exactly the same shape and the same size. And there are three of them, but before I get to them, I'm going to talk a little bit about notation for congruence and how we indicate congruence in pictures. Each of these conditions is going to involve knowing that certain sides and or certain angles are congruent between the two triangles in question. So we might, for example, know that AB and XY are congruent. So I want to show you how we write that and then how we indicate that in the diagram. The way we write congruence between line segments and between angles is we name the segments. So maybe I know AB and XY are congruent. So we name the angles, or the segments rather, and then between them we put the symbol for congruence. And that's an equal with a little tilde or twiddle above it like that. This is the symbol for congruence, and this statement is read, line segment AB is congruent to line segment XY, or more simply, AB is congruent to XY, because the context will tell me that I'm dealing with line segments here. This is how we write it out when we're writing it out on the proofs. But it's very difficult to see what's going on in the picture if all you have is this over here. So there's a very standard and very helpful convention for how we mark congruence in the diagram. And all we do is we find the two objects that were stated as congruent and we put little tick marks on them, little tiny marks. So I put a little mark on AB and then I put a corresponding number of marks on XY, usually near the middle. And this mark is just a visual reminder that we know that AB and XY are congruent segments. They have the same length. And we need to be able to see these marks in the picture and assemble them in certain configurations. Similarly, we indicate that angles are congruent. Maybe I know that angle B here and angle X are congruent to angle X.
And we mark congruent angles either by using arcs or by using arcs with little tick marks on them. Now, one note I want to make is that if I had another pair of congruent segments, for example, maybe I know that AC and ZY are congruent, I wouldn't want to put one tick mark on them by themselves, because this one tick mark has already been used here. This would indicate that this is also congruent to that. If I want to say these are congruent, but they're not congruent to those, then I have to use a different number of tick marks. So I'll put 2. Likewise with angles, if I have different collections of angles that are congruent, I can use multiple little arcs like that, or I can use extra tick marks on the arcs to indicate that these are congruent to one another, but they're not congruent to these. These match, but they don't match those. So this is how we notate congruence, and this is how we mark congruence in our diagrams. So what are the three triangle congruence conditions? These are things that you're going to be using an awful lot. The first one is called side, side, side. And it simply says that if the three sides of one triangle are each congruent to the three sides of another, then the triangles must be congruent. So what that looks like in the picture is very straightforward. Side, side, side is the easiest congruence condition to identify in the diagram. Side, side, side means we have a pair of sides marked, and we have another pair of sides marked, and we have a third pair of sides marked. And this information would be enough to guarantee that this triangle is actually exactly the same as this one. Not only are all its sides the same, but all of its angles are the same, its area is the same, everything about these triangles that we could measure is the same, except maybe their position or something like that. I could lay this triangle directly on top of that one and all the angles and all the sides would match. Just by knowing that all three sides match, that guarantees the triangles have exactly the same shape and exactly the same size. It guarantees that they are congruent triangles. The second congruence condition is a little bit trickier. It's known as side angle side. And here we have our first one with a pair of angles, and here the fact that the angle here is between the s's is important. So the way it works is if two sides and the angle between them
are each congruent to the same between two triangles, then the triangles must be congruent. This is awkwardly phrased, but I'll explain it over here. What this means is if I have two sides, let's say I have BC and AD known as congruent. And then of course here I have BD, which is congruent to itself. BD matches itself. So if I look here, I have a pair of sides in the top triangle marked, and I have a pair of sides in the bottom triangle marked. Let's say I add to this the angle that touches the two sides in each triangle. So what I mean by the angle that touches is literally if you draw the arc that represents the angle, that arc will touch both of the marked sides. The angle goes from one of those sides to the other. It's between these two sides. Some older geometry textbooks say this is the included angle, but I find that to be an awkward phrase. It's the angle that goes from one side to the other, not this angle. That wouldn't work because that doesn't touch both of the marked sides. It only touches one of them. This would have to be here. And in this triangle, it would have to be down there. If I look at these two triangles have the side, angle, side, and the other one has the side, angle, side matching configuration. This pattern of information that we know matches between these two triangles will guarantee that this bottom triangle, triangle ADB, is congruent to the top triangle, triangle CBD. This is the second of our congruence conditions. The last is like the mirror image of the previous one. The last is angle, side, angle. And this says if two angles and the side between them in one triangle are each congruent to the same in another, then the triangles must be congruent. So this is like side, angle, side, but everything's flipped around. Now we know two angles match. So let's say I know this angle matches this one. And let's say I know this angle matches this one. So I use my congruence marks. To finish the ASA pattern, I need the side that goes from one angle to the other in each triangle. So it wouldn't be this side over here. This goes from this angle over to there. In the triangle on the left, the side would be this XM. And the triangle on the right, it would be the same side. It would be the side XM again. That would complete the ASA pattern. So to have the ASA pattern in a triangle, you need to have two angles and the side that touches both of those angles, just like I've positioned the A so it touches both S's. If you have this pattern of information, then you can guarantee that these two triangles are congruent.